Hello everybody, thank you for joining me today. My name is Willem and today we're going to be looking at series circuits. We want to understand how resistance, current and voltage all vary in a series circuit. Now, something that you need to know already are the standard circuit symbols because we're going to be using a lot of them today. If you understand that already, well, let's get right into it. Alright, so now let's start having a look at series circuits. First of all, we want to understand how do we actually recognize a series circuit. So let's draw one out right here. So let's take our cell. So let's have two resistors in series. Now we know that these are series because all of these components are connected one after another. Okay, connected one after another. Now the way that I learned to remember this, it's a bit weird, but I always thought that serial killers all have victims one after another. Okay, so when you hear series, think serial. All serial killers kill one after the other. In a series circuit, all the components are connected one after the other. Okay, so that's our first of all straight up definition right there. Now let's have a look at how voltage varies. Let's change the color of our highlighter here. Okay, let's have a look at how voltage varies in in a series circuit. If this a cell here is 6 volts, the voltage is shared equally. Well, no, actually no, shared according to resistance. Okay, if these two resistors are both say 50 ohms. Remember the omega sign here, that looks like a 60. The omega sign here is how you represent resistance. If these two are both 50 ohms each, they're both an equal share of the overall resistance. I'm going to explain how you calculate overall resistance in a bit, but for now just know that in series you add them together, right? So if these two add together gives you an overall resistance of 100 ohms. Both of these components have half that resistance, so therefore according to that percentage they get half the voltage. So this one here gets 3 volts and this one here also gets 3 volts. Okay, so another way to make sure that that's right, if you have 6 volts going in, you must also have 6 volts coming out, right? So 3 plus 3, 6 volts. So voltage is shared according to resistance. Now what about current? Current, however, is the same across all components. This is the reason why we always connect our ammeter in series. If we want to know the current, that's the same across all the components, right? That's why we connect our ammeter in series. Our resistance, so here we're talking about resistors connected in series as we have here. Resistance is just R total is equal to R1 plus R2, and so on and so on. So this is really just the sum of all the resistances. This is a fancy way of writing it, but here we have R1 and here we have R2. So RT is 100 ohms, and that's really just equal to 50 plus 50, and that's all there is you need to know about the properties of series circuits. It's not that difficult, but as soon as we start looking at parallel, or people start getting confused between the two, but if you do get confused, just remember to come back to this video and rewatch it.